Scan Pro Video brings you a series of webinars focusing on the latest Blackmagic design products and information.
Thanks everyone, thanks for joining us today. I really appreciate your time this afternoon for this webinar. A little bit about myself. My name is Alistair Davidson. I am a certified master trainer for DaVinci Resolve. And today we're going to take a look at the HDR tools and color pipeline within Resolve. So let me just share my screen if I can there. Share my screen. And I'll just quit this just so I've not got any pop-up messages coming on in the background. Okay, so like I said, we're going to cover HDR tools and color pipeline within DaVinci Resolve. And HDR has become a bit of a buzzword over the last couple of years. So we're going to break that down first. What is HDR before we actually dive into it, into how we work with it within Resolve. So HDR in terms of delivery, and that's what the big buzzword around is, how we watch it in our homes, has come about from the development of displays rather than the development of cameras. For a long time now, we've had digital cinema cameras that can shoot, 13 plus stops of dynamic range. And even if you go back and look at some old film, some old 35mm film, I believe I saw somewhere once that it was said that film has around 13 stops of dynamic range as well. So really, it's never been about the capture or acquisition side of things that's been holding us back from doing HDR. It's always been about the display side, how we actually display that at home or, to our audience, wherever that may be. So nowadays, we're starting to see an increase in HDR TVs, HDR displays, all these sorts of things that are coming out. And one common misconception that I see come up a lot is that people believing HDR displays are just brighter. So the white point is brighter for the display. And whilst yes, they are brighter, that's not the only thing. It's not as if we're just taking, all the values of a normal TV and just pushing them up. It has a greater dynamic range, so there's more stops between the darkest point of our image and the brightest point of our image. So what we're doing is we're increasing the sort of specular highlights, but we're also decreasing the darknesses, or increasing the darkness as well. We're making our darks darker and our whites whiter, so we're making more of a range. There's more of a contrast between those. One thing that we'll talk about a lot is how we measure HDR, and you'll hear me refer to it as nits or neats, but they're also known as candelas per square meter, or CDM square. And currently, the way that we work with current broadcast standards and current, say, HD TV sets, generally the max brightness is about 100 nits. So that's what we've got used to over the years. But HDR displays nowadays or consumer HDR displays nowadays can reach up to 1,000 nits. Now, for mastering, for the sort of professional displays, there are displays that go up to 4,000 nits. I believe one of the Dolby monitors, it's either the Pulsar or the Maui, can go all the way up to 4,000 nits. So there's significant advancements in terms of brightness increases when we're looking at HDR displays. And why does this matter? Well, the aim of HDR is to reproduce color and contrast in displays, so that it's a bit of a closer match to the human eye. So we want it to look a bit more lifelike. And if we're doing that, we need to understand a little bit about how the human eye works. So the human eye is really adaptive in terms of what it can do. It's able to make out detail in really sort of dark environments. If you're in a room with all the lights off and the curtains closed, you can still make out some details in there. And if we were to step out into the middle of a desert, our eyes would adapt to that. So we can see, really bright, our eyes will adapt so that we can see in really bright environments and really dark environments, but it doesn't do it all at the same time. As I said, our vision has to adapt to that. We can, if we're in the middle of a desert, we can't see all the detail in shadows because the human eye is only capable of seeing about 10,000 nits at any given time. So in our sort of real world example here, if we're, outdoors in direct sunlight, you're looking at 1.6 billion nits. Daylight, maybe a bit overcast, a bit of cloud, you can be anywhere from sort of 100 million to 1 million nits in there, all the way down to sort of starlight, which is like 0.000001 nits or whatever it is. And our eyes will adjust to that. So the human vision really is capable of seeing up to about 100 million nits. This is where we top out. So we're never going to, we don't go outside and stare at the sun. It's not the smartest idea, but you're also not going to be able to make out any detail because it's just too bright for us. But what we do have is about a 10,000 nit range that scales or adapts up and down depending on our viewing environment. So that's sort of represented here on this scale that we have. So if we are in a moonlight situation where the darkest thing we're going to see is 1,000 nits, we have sort of 10,000 nits around that that we can view at any given time. Now compare this to our display formats, things like HDR TV, SDR TV, and cinema. You can see there's a huge reduction as we start going down. We talked there about how SDR displays, the current standard for broadcast, are 100 nits, and we've jumped up to 1,000 nits. So that's a massive leap in terms of display technology, but it's still only a tenth of what the humans can see, the human eye can see at any given time. Now, you might wonder why we're generally aiming for about 1,000 nits when we're working with sort of consumer displays. And there have been tests, as I mentioned, there is a display, or there are a few displays that actually go over that. There's displays, that are 2,000 or 4,000 nits. And there have been tests done with displays up to 10,000 nits, but it was just too bright really for home use. So 1,000 nits was sort of that sweet point that they found in studies for home viewing. So that's generally where everything sits. So you can see in this as well, like I said, it's not just that HDR TVs are brighter. You can see that they also have a lower level in the shadows, so they have a greater dynamic range, and that's a lot about what we're talking about. This high dynamic range, or HDR, that we're talking about, it's all about the contrast, the amount of stops that we have between our darkest point and the brightest point in our image. So what does this look like in terms of a real world example? How are we expecting to see this? Well, if we took SDR content and just sort of bumped it up really, so we took our brightest point in an SDR file, which would be 100 nits, and we suddenly made that 600 nits. Well, we're going to raise the black point as well. We're basically just brightening our image. We're not doing anything to it to increase the dynamic range. You're just sort of boosting up the highlights of it. Whereas we can see over here on the right hand side, if we're looking at an HDR display, we can see that we have that greater dynamic range of our shadows being much darker, all the way up to our 600 nits highlights here. And you're probably going to hear me mention this a couple of times. I've already done it once, but HDR, especially when we're grading HDR, it isn't about making our image just brighter. That's not the goal of HDR. It's not to just suddenly, make our whites absolutely sort of like bright, blindingly bright. It's about leveraging the increased dynamic range that we have. So how do we achieve this? And this is generally how any workflow goes. This is On the left-hand side, we have our camera. On the right-hand side, we have our display. So we have the visible light in our scene. That could be, you know, if we're shooting outdoors, it could be from the sun, it could be from on-set lighting. And this is our scene light. This is what we see. The camera then captures that through the sensor and encodes that into image data. But to do that, it uses what's called an OETF, or optical electro transfer function. So optical is the visible light, what we can see. The electric or electro part is the signal that's created, and the transfer function is how we take the optical and make it the electric or the electro part. So it can be a little bit confusing, but we're taking optical light, that visible light, and we're making it into a signal. That's our OETF. We're then doing the inverse of that when we come to display that on a monitor. We're taking a digital signal and we're making it visible light through our monitor. And that's where we have an EOTF, an electro-optical transfer function. And this is where the sort of big breakthrough, the big change has been when it comes to HDR displays. It's about how we take this digital signal and we replicate it on a display. And that's about as deep into that as we have to get. We don't need to start worrying about how it stores all the bits and things like that. It's going to be a little bit dry, this next part, especially because it's a lot of it's graphs, it's technical stuff. But we're going to sort of touch on some topics. We're not going to dive in too deep to them because obviously, you know, we've got a limited amount of time, and like I said, it can be quite dry. I don't want to bore everyone to death. So, what does an electro-optical transfer function look like? Or what do the HDR EOTFs look like compared to our SDR EOTFs? So EOTFs has been used for sort of flat panel TVs in SDR and broadcast that we have at the moment is known as BT 1886, and it's commonly used for delivering content in the BT 709 color space, or Rec 709 as you might also know it. So that's effectively the blue line on our chart here. So this is what we have from sort of, you know, roughly sort of 10 nits all the way up to 100 nits. And once it reaches that 100 nits maximum that we mentioned earlier, you can see it levels out there. We do have a 10-bit version of this, which is this sort of reddish, this black line. You see it sits underneath the reddish line at the beginning, but then tails off a little bit as well here. So it's designed to sort of reduce any sort of banding that we'll see when we get into sort of the highlights up here. And that's the 10-bit version of BT 1886. What we have for HDR is we have two new EOTFs. The first that we're going to talk about is what's known as the PQ, or Perceptual Quantizer ST2084 curve. And this was developed by SMPTE, which is the Society of Motion Picture and Television Engineers. And they developed this for HDR viewing, and that's this sort of orangey line on our graph here. And you can see it goes all the way from 0.0001 nits all the way up to 10,000 nits. So even though, you know, the brightest monitor available at the moment can do 4,000 nits, this curve's designed to work all the way up to 10,000 nits, all the way up to the range of the human eye, as we mentioned earlier. So really, it's not just about, obviously it's a lot brighter, but also it has a lot more in the shadows as well here. So it's got a much brighter range. The PQ, the Perceptual Quantizer EOTF, even though the graph sort of bottoms out at 0.0001 nits here, the actual range of it is actually 0.00005 nits up to 10,000 nits. I had to count that on my hands there because just repeating zeros, I always get lost. So it's basically the range that the human eye sees. But what you'll see is we have the second one. I mentioned this earlier. We do have a second one. We sort of touched on it. The fact that it's this red line that actually covers up the bottom half of the BT 1886 10-bit curve. And that is what's called HLG, or hybrid log gamma. And as you can probably guess from what we've got here, the hybrid part is because it mimics the existing EOTF for SDR as we get up to about 100 nits. So from sort of, 1 or 0 up to about 100 nits, it's roughly the same. As we start to go beyond 100 nits, it diverges all the way up to 1,000 nits. And this was developed, HLG, or hybrid log gamma, was developed by NHK in Japan and the BBC to bring a sort of backwards compatible, broadcastable form of HDR out. So that's why it sort of mimics this this current curve that we're using, so that if you were to view it on an SDR TV, you're only going to lose anything above 100 nits. Everything below 100 nits should be identical. Anything above it, you will lose, it will clip. Whereas if you were to do that with a PQ, an ST2084 image, it's going to look significantly different on an SDR TV versus an HDR TV, because the EOTF is significantly different. And again, what the EOTF does is it maps our digital signal to the luminance of the display. So that's how we handle luminance, at least with HDR. But HDR isn't just luminance. It's not just, darker shadows, brighter highlights. Because we have more of a range of luminance, we have more stops, more brightness values that we can display a color at. So we also have to now consider the color space that we're working in as well. And like we sort of touched on in that last slide, Rec 709 is the current SDR color space. And you can see that over here on this diagram on the right hand side. It's this solid line triangle. What this graph represents is a 2D version of the range of visible color to the human eye. So this was the CIE CIE visual sort of representation. It was done in like 1931, I think it is. And like I said, it's 2D representation of colors that the human eye can see. So when it comes to Rec 709, you'll see that we're actually not using a great deal of what's visible to the human eye. And this is where other color spaces step in when we get to HDR. Because we now have this expanded luminance range, we need an expanded color range to go with it, or an expanded gamut. When we're talking about, color space or the range of colors that a display can show, we're talking about the gamut that display can show. So what we've got here is we have two. We have P3 with a D65 white point, and P3 will be sort of familiar to those that have worked, in sort of cinema and things like that a little bit as well. It's been around for a little bit, but we also have this newer, larger color space as well, which is Rec 2020. And this Rec 2020 space was developed specifically for Ultra HD and 8K TVs. So it's, as you can see, it's absolutely massive in terms of the range of color it can show, especially when compared with Rec 709. One thing that it's worth noting really is that when we're talking about HDR delivery, whether it's hybrid low gamma HLG or ST2084, whether it's P3 or Rec 2020, it's always going to be at the minimum 10-bit. So the delivery is either going to be 10 or 12-bit, but you'll never deliver that in 8-bit. So it's always something worth keeping in mind there. We've only got a few more slides, so we'll dive into Resolve in a little bit. I just want to get through all the HDR bits first. So we've talked about EOTFs and color spaces. This is more of a sort of visual representation of the workflow. So we shoot whatever we need on our camera, and we're going to bring it into Resolve. And this is the part we're going to look at in a minute. It's how we take or how we set Resolve up to work in our HDR profile. And when we're doing that, what we need to consider is the EOTF. So again, we need to know whether we're using the ST2084 EOTF or the hybrid log gamma EOTF. And then we also need to consider what color space we're using, whether we're doing it as P3D65 or Rec 2020. And these will sort of depend really on what standards you're delivering for, what your delivery specs are. So if we have a look here, there's 4 sort of major HDR standards. There are more, there are a few more standards for HDR, but these are the 4 main ones that you'll come across. There's Dolby Vision, HDR10+, HDR10, and hybrid log gamma. So Dolby Vision, or what we'll do is we'll go through what they support, what to sort of look out for with them. So Dolby Vision, HDR10+ and HDR10 all use the ST2084 EOTF, whereas hybrid log gamma obviously uses the HLG EOTF. What we're also looking at is the color space. So we've looked at the EOTFs. What we're also looking at is the color space. So generally, Dolby Vision will be delivered in P3D65, whereas HDR10+, HDR10, and hybrid log gamma are all delivered using Rec 2020 as a general rule of thumb. But it is worth noting that Dolby Vision supports Rec 2020, and the other 3, HDR10+, HDR10, and hybrid log gamma, do support and can be delivered in P3D65. The only sort of final outlier is that hybrid log gamma, because it's designed to be backwards compatible with SDR displays, can also be delivered using the SDR standard, the Rec 709 space as well. So let's have a look at how we set this up in Resolve. There's multiple different ways of doing this. There's multiple different ways of taking your content and getting it into an HDR space for grading and for delivering as well. And we're going to have a look at a few of them. The first one that I will sort of touch on isn't one that I generally tend to recommend, just because of the inherent nature of LUTs. So we can use LUTs or lookup tables to convert to and from HDR spaces. The big problem that you'll get with LUTs that sort of anyone that's worked with LUTs has come across is that they are a mathematical transform from one set of values to another set of values within a finite range. So what I mean by that is anything that's sort of outside of that range is going to be clipped or lost or ignored. So really you are limiting, or you are limited a little bit when using LUTs. It's not to say it can't be done, it's just you have to be aware of the confines that exist when you are working with LUTs. So the first thing I'm going to do is I'm going to open my LUT viewer, my LUT gallery in the color page, and you'll see down the left-hand side of it, I've got 2 different folders. One for HDR hybrid log gamma that can convert to or from HLG, and the same with HDR ST2084. So I'm going to use ST2084 for this. I'm going to use sort of Dolby Vision as the main standard that I'm going to theoretically deliver for here. And I can hover over these and I can apply them, or I can look to apply them, but you'll notice that it's not doing the best job. And it's because these LUTs are expecting if I was to use, say, this first one, Gamma 2.4 to HDR 1000 nits, it's expecting an SDR source file. It's expecting a Rec 709 Gamma 2.4 source file, and that's not what I have. I have a Blackmagic raw clip here on my timeline. So if I come across to my camera raw controls and I just decode using the clip, and I'm just going to change my gamma to Rec 709 there. I can leave the color space, it's Blackmagic Design. I wonder if I could change that to Rec 709. But you'll see now I get a much more accurate view when I hover over that LUT. So if I right click and apply that LUT, there we go. We've converted from Rec 709 or Gamma 2.4 to hybrid log gamma. Again, I can change that back to Blackmagic Design as a color space if I wanted to. So there we go. That's the sort of quick and simple way of working with LUTs and using them to sort of convert clips within Resolve. But as you'll notice, that's a per clip basis. It's a little bit fiddly. If we've got a few Blackmagic raw clips on this timeline. If we've shot everything, on the same camera or cameras, we know the values for them, and we want to convert the entire project in one go, we can do this using what's called Resolve Color Management. And what I'm going to do is I'm just going to open up the project settings, and you can do that down here in the bottom right-hand corner of Resolve using this little cog icon. And I'm on the left-hand side, I'm going to come down to color management. So what you'll see here, by default, color science is set to DaVinci YRGB, DaVinci's own color science for all the processing that it does. But if I click on this drop-down menu, you'll see I've got a few other options. We're not going to have a look at ACES just now. We'll come back to that in a minute. What we are going to look at is DaVinci YRGB color managed. And once I turn that on, I get a few more options in here. So we have a Resolve color management preset, and we have an output color space. And our output color space is what we're going to deliver for. So this is what we're converting everything to. So at the moment, you might have it set as something like Rec 709 scene. So I'll leave it as that for just now. And I'm going to change my Resolve color management preset. My Resolve color management preset is the space that Resolve does its processing in. So it affects how the tools feel. By default here, it's set to 709, SDR 709. But what I'm going to do is I'm going to select this DaVinci wide gamut. So I'll come back to this, like with ACES and things like that. I'll come back to this in a little bit. What is DaVinci wide gamut? Basically, it's an absolutely massive color space that's been designed by the Resolve team. And the way that it works with its own OETF, its own optical electro transfer function. And it's just designed to give that sort of maximum image quality. And it supports up to 10,000 nits as well. So it's really sort of where we want to be if we're doing HDR work in general. So got DaVinci wide gamut. Where were we? DaVinci wide gamut. So currently I set this to DaVinci wide gamut, but what I'm actually going to do is I'm going to change this to this custom option. And the custom option, you'll see, gives me a massive range of controls now. So it gives me much more control about how I set up my color pipeline. So currently I've got this Resolve color management preset set to DaVinci wide gamut. But what I'm actually going to do is I'm going to set this to custom. And what you'll see is it gives me a much wider range of options here. And we're not going to go through each option in depth. You can do this in your own time if you want to. The Resolve manual covers quite a lot of stuff on this. But basically what we are concerned with is our input color space, our timeline color space, and our output color space. So right now, our input color space is set to Rec 709 Gamma 2.4. This means that in the timeline, Resolve is going to see all the clips. it's going to assume all the clips that aren't specifically tagged as Rec 709 Gamma 2.4. It's then going to convert them into my timeline color space, which is DaVinci Wide Gamut, using the intermediate EOTF or OETF that we talked about. And then from there, it's going to convert everything once it's in this large color space out to our output color space, which is currently set to Rec 709. But I'm going to set that to be Rec 2020, ST 2084, 1000 nits. So what we've got here is we convert from our input color space to our timeline color space and then to our output color space. Now, one thing that it's worth noting is because I'm working with raw files here on the timeline, we have lots of Blackmagic raw files. The input color space option doesn't actually do anything. I could, change this to whatever I wanted. In fact, if I do that, if I change it to say, let's pick something. Let's say it's CIE XYZ. Why not? And I'm going to save that. And now if I change it again, so let's pick something random. Let's pick a red option, hit save. You'll see it doesn't change. Once I've applied the color management, the input color space option isn't having an effect at all on my raw clips. And the reason is because Resolve looks at the metadata of these raw clips, identifies that they are in fact raw clips, and then identifies how it should decode them. So what we're looking at here is basically Resolve identifying raw clips on the timeline, bypassing the input color space option and saying, no, I know what color space these clips are. I know how to convert them to my timeline color space. If I had QuickTime clips on the timeline, it would be a different story. They would use the input color space, or I could go in and manually tag them. So I'll show you that just now, actually. In fact, before I do, there's two more options that I'll have a look at here in this custom bit here. So the two options that I'm going to mention is this limit output gamut 2. So we've talked a bit about how Dolby Vision uses the P3 D65 standard for delivery, but what you might come across is people asking for the P3 D65 color space in a Rec 2020 container. So what you'll get here is my output color space is set to Rec 2020 ST 2084 1000 nits. So that's the container that it's all going into. But with this limit output gamut 2 option, I could set that to be P3 D65. So my output gamut is going to be P3 D65, but it's going to be inside this output color space container. It's just a handy one to know about. The other option that we have here down at the bottom is HDR mastering is for. So if I tick that to enable it, and it'll pop up, and by default it's on 1000 nits. And what that does is when we're using consumer displays, we have to manually trigger those consumer displays into HDR mode when we're grading. But we also have to tell them what our max nit level is when we're doing that. So generally what you do is you'd set this to be, the maximum nit level of the display that you are currently working with as a grading display. So that's it. That is how we set up color management really for Resolve on a project-wide basis. So what I'll do is I'll actually just set us back to camera metadata. And all of our clips here, it doesn't look as though a lot is happening. And a big part of that really is because the viewer in Resolve can't read or display the HDR EOTF. So when it comes to monitoring HDR content, you really need an HDR display connected to a suitable I/O device like a DeckLink or an Ultra Studio, because it's really difficult to see this. It looks really flat. It doesn't look as though there's a lot of dynamic range in this image at all. But if I was viewing this on a in fact, I'll reset that node grid because that's probably not helping having that LUT on. But again, it still doesn't look super bright. But really what we're looking at here would look completely different on an HDR display. So like I said, it looks quite flat in the Resolve viewer, but what we really need is an I/O device with an HDR monitor connected to really see the HDR image. So I'm just going to jump across really quickly back to my presentation here, because I touched on the DaVinci Wide Gamut as the timeline option here. And you'll recognize, again, this CIE chromaticity diagram. And you'll recognize, you know, Rec 709, P3, Rec 2020. Well, this orange line, this orange outline, is the DaVinci Wide Gamut option. So you can see it fully encompasses even the sort of largest Rec 2020 color space, as well as P3 and Rec 709. So it's absolutely huge in terms of what it can do. And because it's so large, there shouldn't be any loss in color fidelity. Now, to accompany the DaVinci Wide Gamut space, all that sort of color information, there is the DaVinci Intermediate OETF. So it's a log-based transfer function, and it allows the encoding of up to 10,000 nits. So again, that maximum sort of visible range of the human eye, the DaVinci Intermediate OETF supports. So using the two of them together, using the DaVinci Wide Gamut and the Intermediate OETF, basically just means that if we are working from clips from, you know, different cameras, if we have stuff from a Blackmagic camera, an Arri camera, a Red camera, you know, a Panasonic camera, whatever it is, we can bring them all in into Resolve. We can work on them in the same working color space, meaning that sort of all the controls that we have should work the same, should feel the same across the different camera profiles. And it just makes sort of matching these shots a little bit easier without any loss of dynamic range or, again, color fidelity. So that's a little bit on the DaVinci Wide Gamut stuff. Now, I also mentioned ACEs, and I said we'd come back to it. And if I open my project settings again, color management is fantastic within Resolve. It works incredibly, but it only works within Resolve. If we are handing off, you know, to a VFX house, we're sending them, you know, EXRs, or they're sending us EXRs, you know, they're not going to, odds are they're not going to be working with Resolve. So the DaVinci Wide Gamut space isn't really an option for them. And this is where ACEs comes in. So if I change my color science down to ACEs, it works on the same idea. We have our input device transform. We're telling Resolve how we are going to convert, or what color space our source files are, so we can convert them into the ACEs space. Again, with raw files, it works the same way as it does with Resolve color management. So Resolve will automatically detect what color space and apply the correct transform into ACEs for raw files without you having to do anything. But if we had, you know, like I said, if we had QuickTime files, you know, that were shot on, you know, a Canon C500, or, you know, just picking any sort of random examples, we can apply our input device transform in here. And then our output device transform is, again, what we're delivering to. So when we have transformed our source files into the ACES space, what are we transforming them all back out to? So again, I could set this to be, you know, P3 ST2084 1000 nits, you know, Rec 2020 P3 limited. You know, there's a ton of options in here. I'm just going to set that to P3 ST2084 1000 nits for just now. So that's how ACES works. Again, it works very similar to RCM, but is supported by a wider range of applications. So if you're doing handoff between facilities or anything like that, ACES is really sort of the go-to in that space. Now, I mentioned there with both Resolve color management and ACES manually tagging files. So, you know, we've got this DNX HR HQX file in the timeline. if I right click on that, you'll see we have this ACES input transform here, and it's currently using the project, which is set to no input transform. Now I can go in, if I right click on the clip and go to ACES input transform, I can set that to be whatever. It might be, you know, Blackmagic Design 4.6K film V3 or whatever it is. And I can do that for clips on the timeline. If Resolve doesn't recognize any metadata tag and can't apply the correct IDT or transform and Resolve color management, you can go in and you can do it manually. Again, in ACES, it's called the ACES input transform. If I was going to go change my color science back to Resolve color managed, hit save, I could get the same thing. So input color space. And you can see you can just choose from any of those options there. So again, that's us doing color management, but on a clip by clip basis. There is another way to do a clip by clip color space transform as well if we want. What I'm going to do is I'm going to turn, just going to switch back to DaVinci YRGB at the moment and hit save. And I'll come back to this clip, this last clip we have here, which reset everything, just make sure we're back to scratch. There is another way to do it on a clip by clip basis, and it's using open effects or Resolve effects that are built into the application here. So what I'm going to do, I'm just going to resize my viewer a little bit actually, and I'm going to open up my open effects window here. If I come down a little bit, under Resolve FX Color, you'll see that I have a color space transform OFX. So I can click and drag that across to this node. And in the settings now, you can see I have all the Resolve color management controls that I had in the project settings. So again, I know this was shot on a Blackmagic Pocket 4K, I believe. So Pocket Film 4K. And do the same again, Pocket 4K Gen 4 for our input gamma. Now it's going to our timeline color space, which we open up project settings, we can see is Rec 709 here. Now I could change that to be, you know, DaVinci Wide Gamut if I wanted, or if we're doing it on a clip by clip basis, I can do that here on the output color space and output gamma. I'm going to select DaVinci Wide Gamut, and should be DaVinci Intermediate there. So there we go. I'm now transforming from source color space to DaVinci Wide Gamut. If I add another node, so Alt S, and I do the same thing, I apply a color space transform node, except this time I'm not going from Pocket 4K, I'm going to go from the DaVinci Wide Gamut space because that's what we converted to with our first node. So I'm going to go from DaVinci Wide Gamut and the DaVinci Intermediate Gamma to whatever HDR output I want. So in this case, I'm going to do P3D65 and I'm going to do ST2084 1000 nits. And there we go. We've basically done the same thing that we were doing in color management for the whole project across a single clip using the color space transform nodes to transform from the source space to DaVinci Intermediate and DaVinci Wide Gamut, and then the second nodes go from DaVinci Wide Gamut to our HDR deliverable, and we can grade in between this in any way that we want. So last thing on this, I guess, if I reset all of this, the last thing to note is that's the color space transform I've been using, which is the Resolve equivalent basically. But there is also an ACES transform, which does the same thing. So your input transform and your output transform, you could do the same thing in there if you wanted. So that's how we get our clips from their source space to an HDR deliverable. That's how we set up the sort of pipeline roughly. But again, it's difficult to show. So the Resolve user interface doesn't support displaying HDR content. On top of that, we're also streaming via Zoom. So you're going to be limited in what you can see, you know, regardless of whether it's HDR or not, it has to be compressed to be streamed. So this is where monitoring comes in really important. And this is the next bit that we're really going to touch on. If I come back to the presentation here, Monitoring is the sort of biggest bit that we're really going to touch on. And like I said earlier, what we need is an HDR display connected to an I/O device or a capture and playback device, basically a way of getting a video signal in and out of our computer. And Blackmagic obviously produce a range of these. They produce their deck links, their Ultra Studios, and their Intensity I/O devices, but not all of them are suitable for HDR. So this is the sort of list of what you can use if you're looking to work with HDR, if you're looking to monitor HDR content. You obviously have the high-end models, which are like the DeckLink 8K Pro, the DeckLink 4K Extreme 12G, the Ultra Studio 4K Extreme 3, and the Ultra Studio 4K Mini. So these are the sort of high-end devices that are specifically designed with these 4K and HDR workflows in mind. But there is also this DeckLink Mini Monitor 4K, which is actually one that I have in my system, and I think, you know, it's 100 and something pounds, or you know, maybe just shy of 200 pounds. It's really not a great deal of money, but it does have a limitation. So that limitation is that it's not usable or not suitable for Dolby Vision or HDR10 plus delivery. So if we're doing, you know, HDR10 or we're doing hybrid log gamma HLG, the DeckLink Mini Monitor 4K will work. But in order to have a proper Dolby Vision or HDR10 plus workflow, we need two SDI outputs from our device. And as you can see from here, the Mini Monitor 4K has one SDI and one HDMI. So it doesn't really meet the requirements for what we need it to do. Worth noting that obviously the DeckLink Ranger PCI cards, they're internal. The Ultra Studio are external devices that connect over Thunderbolt, or in the case of the Ultra Studio 4K Extreme 3, I think there is also a PCI card and adapter that you can use for that as well. So if you want internal, go DeckLink. If you want external, it's Ultra Studio. So that's the I/O side of things. The next part of things is actually the monitor, really. So what monitor do we want? Do we need? And Blackmagic don't certify monitors for use with HDR, with Resolve or anything like that. And neither do Dolby, who obviously make Dolby Vision, or Samsung, who are the people behind HDR10 plus. They don't certify, you know, mastering monitors like, oh, it has to be this or whatever. What are a good resource really is the Netflix Partner Help Center, which sounds a little strange, but if you're delivering, you know, HDR content for, you know, if you're delivering like Dolby Vision content for Netflix, or, you know, Dolby Vision content for anywhere, this Netflix Partner Help Center is a fantastic resource for understanding the sort of mastering process, what you need, how you set it up, and the sort of equipment you need. So in here we've got, you know, Dolby Vision HDR mastering. I'm not going to go through everything, but it gives you a rough idea of the sort of specs you want to be looking at. So color gamut, white points, EOTFs that it supports, all these sorts of things. So it's a really handy resource for anyone looking, you know, who's considering getting an HDR monitor and doing some HDR work. But generally what it boils down to are the main sort of points you want to look at, and I've got them sort of listed out here. So the support for the ST2084, that PQ EOTF, a minimum support for the P3 color gamut. Obviously, you know, if you can support more than that, that's great. But the P3 gamut is the minimum. You want to support as much of that as you possibly can, if not the full thing. So that's important. Minimum peak luminance of 1000 nits. So this is where we get into the range of, we were talking about earlier, consumer displays tend to top out at 1000 nits. Mastering displays, you know, you want a minimum of 1000 nits. A minimum static contrast ratio of 200,000 to 1. And this is kind of a one that will catch people out, and it's that a lot of TV manufacturers or display manufacturers do stuff with localized dimming to sort of try and stretch the dynamic range. And these will boast things like a contrast ratio of like 1,000,000 to 1. But this isn't a static contrast ratio. So it's always worth just being aware of that. We want a minimum static contrast ratio of 200,000 to 1. We want support for a 12-bit SDI signal if we're doing Dolby Vision. We also want an SDI connection, obviously, and no tone mapping. We don't want the display to do any of the tone mapping, because we are going to do that at a later stage. Now, what display should you get depends. The most common sort of reason for going with one over the other tends to be budget. Obviously, professional grading monitors are expensive. SDR grading monitors are expensive. So HDR grading monitors are incredibly expensive. There are models from, Flanders, Sony, Dolby, as we mentioned, but we're not, we're looking at tens of thousands of pounds here. So that's where, we can get HDR dedicated displays. So, things like the one shown there is an Asus ProArt monitor. And you can use domestic TVs as well, although there are a range of limitations that come with that. And we'll talk about those in a second. Rather than sort of go through all the different, points and break it down and read a PowerPoint to you or a keynote to you, it's not engaging. Generally, these are the sort of three categories they get split up into. If you're doing Dolby Vision and you're doing, mastering for Netflix or anything like that, a professional grading monitor is really where you want to be looking. If you're doing, HDR10 or anything like that, then HDR displays, or possibly a domestic TV, but you need to be aware of the limitations with that. If there are any sort of questions that pop up, or anyone wants to know, like, oh, what's best for me or anything like that, don't hesitate to contact us. The Scamper Video team are happy to help you with sort of breaking down what you might need, what would suit you best. So drop us an email and we can take it from there. So I mentioned that domestic TVs can be used, but they do have a lot of sort of gotchas that you've got to be aware of. So really, I would only recommend using them if you're aware of these and you know how to sort of manage them. If it's a client display, it's somewhere else where the client's just viewing that and you're viewing the professional grading monitor or something like that. That's okay. You're seeing you have a reference point, but like I said, professional grading displays are expensive. So we might end up with a situation where we have a domestic TV. So really, the things to be aware of: HDMI only. So you're not going to be doing HDR10 Plus or Dolby Vision on them. Really, you're going to lean towards HDR10 and HLG if you're using a domestic display. They have a lot of automatic processing, and the processing that they do can vary from model to model and manufacturer to manufacturer. So really, what you're looking at there is that a grade could look quite different on one TV versus another, just based on the sort of automatic processing that model of that manufacturer's TV is doing. Same issues you'll get with things like the color, the gamut coverage as well. So as you're going to be working sort of, if you're doing HDR10 or HLG, you're going to sort of be working in the Rec 2020 space. These monitors these displays aren't going to like fully cover the Rec 2020 space. There is, as far as I know, there isn't a monitor that covers it, whether it's professional or domestic anyway. But when you get into domestic sort of TV sets or consumer TV sets, you might start to experience different colors from one monitor to another, just because the gamut's nowhere near as wide as you would get on a professional display. The same thing goes for automatic brightness settings. So things like automatic brightness limiting and average picture level. One of the things you'll get is, especially if you're grading in HDR, it's something to be aware of. These settings will basically try and stop them from damaging their screen, so they'll limit the brightness of the signal. And if you're grading, if you stop and grade on a single frame rather than playing through and going frame to frame on a specific clip, you might not know that the TV is limiting the brightness, so you might end up with your grade looking completely different than it actually is when you hit play versus when it stopped. So those are some of the things to be aware of. If you understand the limitations of sort of TVs and you know that the grade might not be 100% accurate, then there's no issue with using them. It's just something to be aware of. And tone mapping, again, we've mentioned tone mapping, but what is it really? And tone mapping is basically how we map luminance and color from one profile to another. So in this example here, we have an 800 nits image. And if we don't apply any tone mapping to it, and we go to a 400 nits file, we're just taking the same image and we're just throwing it up on a 400 nits display, you'll see that our shadows aren't as dark, but our highlights just clip. So anything above that 400 nits value, because it's not been mapped down to 400 nits, because it's not been sort of brought in line with our new maximum nit value, it's just going to clip it, cut it off. And that's what we see on the bottom. We see a tone mapped version where we've tried to basically scale down our 800 nits image down into our 400 nits range down here. So that's a little bit on monitoring in Resolve. And we'll have a look at, that's why monitoring is important, and you've got to consider a lot of aspects to it. But we'll have a quick look at how to actually set it up in Resolve really quickly. It's not too difficult. It's the same way we'd set up any video I/O device. So the first thing you want to do is you want to make sure your video I/O device is detected within Resolve. If I go to DaVinci Resolve Preferences, or use Control, or Command, if you're on a Mac, and then under System, we go down to Video and Audio I/O here. You can see I have a Decklink Mini Monitor 4K in my system. We just want to make sure that that's selected for capture and playback, or for playback at least anyway. So once you've installed your device and installed the drivers for it, make sure it's selected in Resolve, otherwise you're not going to get a signal out of it at all there. Once we've done that, we're going to open the project settings. And instead of being under color management, we're going to come up to master settings here. And it's this video monitoring section that we're concerned with in the middle here. So obviously video formats where we choose to set the resolution and frame rate that we're outputting from the card to our display, but we're not too worried about that at the moment. What we're concerned about is things like use 444 SDI. So you want that to be selected if you're working with HDR, specifically over SDI, because a lot of HDR displays don't support chroma subsampling, so 422 signals. So HDR displays don't tend to support that. They want a full RGB 444 SDI signal. So we want to make sure that that's selected on there as well. Generally want to make sure that data levels, instead of being on video like we would have for a standard broadcast workflow with an SDR range, we want to make sure that they are set to full range. And we'll cover sort of data levels in a little bit, because they tend to catch a lot of people out, even in SDR. So we'll do just a sort of quick bit on them to try and demystify them a little bit. The only other two settings that we want to have a look at really and consider are the use dual outputs on SDI. So as we mentioned, HDR10, HDR10 Plus and Dolby Vision need two SDI outputs. It's the reason that we can't use the Decklink Mini Monitor 4K for HDR work for those two formats, the Dolby Vision and HDR10 Plus. So what we want to do if we're doing an HDR Dolby Vision grade as an example, we want to make sure that that's selected, because when we do our trim pass, we're going to send out an HDR and an SDR signal, each on their own SDI output from the device. And we'll touch on that a little bit later as well. The last option we're going to look at is the Enable HDR Metadata over HDMI tick box just down here. And if you think back to when we were setting up the color management stuff and we were setting the neat value for the domestic TV that we're working on, I said we have to trigger consumer displays into HDR mode. Generally, TVs and things like that don't just have a button to trigger their HDR mode. It has to be triggered by a metadata flag, and that's what we're enabling here. So this Enable HDR Metadata over HDMI, we're basically enabling a flag to trigger our display into HDR mode if we're using an HDMI connection. And once we've done that, all we have to do is hit save. And we've set up monitoring for our HDR content. So what we'll do, go back. It's a lot of jumping around between the presentation and Resolve, and it's a little bit confusing at times. So hopefully we're not going to do too much more of it. I don't think after this, we're pretty much going to dive into sort of grading, and then the final bit will be delivering. So maybe just a few more slides. So video and data levels, why did we use, we're referring to them as data levels here, but in Resolve, they used to be called data levels. They're now referred to as full levels. It's the same thing. It's just a slightly different change in the name. So why did we use data or full levels, and what's the difference? What are they and what's the difference? So video and full range levels, they're important to remember in Resolve because they sort of run underneath the entire workflow from ingest to delivery, and you want to make sure that they're correct. So when we import clips into Resolve, Resolve will try and automatically detect whether a clip was shot using full range or video levels. And it will try and map them correctly. So basically, when you import, if you import a full range clip, if you import a clip that uses a full range signal, Resolve's not going to map it at all, and it's just going to pass it through. If we import a video range clip, Resolve's going to map that out to full range and then down to video levels again when we export, or at least that's what we would aim to do. Resolve tries to bring everything in line during the import process. You can change it manually, but we're not sort of going to get bogged down on that. The one thing we really need to be aware of is what we're monitoring and what we're outputting. These are the things that we need to be aware of, because if we don't take this into consideration, there can be noticeable gamma changes from the grade that we see in the user interface and the delivered file, or the grade that we see if we were monitoring, video levels on our output monitor across our I/O device, and we delivered in full range, or vice versa. We're going to see a significant difference. So what is the difference between them? It's not a massive difference, but it is noticeable difference, and really it's where our black and our white point sits. So data levels are full range levels. Our black point is at 0, and we're talking 10-bit values here. So our black point would be 0 and our white point would be at 1023, and you can see that sort of represented in the scopes here. If we're talking about video levels, generally what you deliver for broadcast, your black level is slightly raised, so it's 64, and your white point is sort of 940 to 960 on the scopes here as well. So that's really the difference between them. But that slight misunderstanding, you can either see your image all of a sudden looking washed out, or you can see it where the highlights and the shadows are clipped or crushed or clipped. It's just that small difference can change the sort of tonality of the image very quickly. So what do we need to consider? Again, a visual representation of what we're sort of roughly looking at are a good way to sort of approach it is generally, ProRes 422 or, sort of more compressed codecs from consumer cameras or things like that tend to use video levels. So it's listed there as a 10-bit YCBCR codec. That chroma subsampling tend to use video levels, whereas raw files like Blackmagic RAW, R3D, things like that, tend to use the full range profile. So what happens is we import these into Resolve. Resolve does its best to automatically detect, what level these clips are at, works on them with 32-bit floating point precision, and then we can both monitor at one set of levels and deliver at one set of levels as well. So we generally want to make sure that we're setting everything correctly. So a little bit off topic there. The thing to sort of consider is generally if you're working in HDR, you're going to be working in full range. Again, like we said, most HDR monitors don't do chroma subsampling, so generally it's a 444 SDI signal. You're generally going to be working in full range. You're not going to be working in video levels if you're doing HDR deliveries. Okay, so let's get into how we actually do a grade in this new sort of pipeline. So I'm going to jump back into Resolve just here. And the first thing I'm going to do before I do anything is I'm going to make sure that my scopes are set up correctly. So right now you'll see I have 10-bit scale on the right-hand side, 0 to 1023, and I have my parade in here. I'm going to come to the three-dot menu in the top right-hand corner of the scope. So I'm going to come down to waveform scale style, and you'll see 10-bit, 12-bit, percentage, millivolts. There's also HDR, so SD2084 and hybrid log gamma. And we can choose between video level and data level here. I'm going to leave it on data level because, as we talked about, that's generally what we'll be working in for HDR deliveries. And I'm going to set the waveform style to HDR. And you'll see instead of having 0 to 1023, my 10-bit values, I have 0 to 10,000, which is my neat range. So first thing I'm going to do, actually, before I do any of this, I'm going to jump back into color management. I came out of the color manage mode there whilst I was demonstrating things, but now I'm sort of jumping back in. So the way that, let me reset my user interface as well while I'm at it. There we go. So the way that you grade HDR content doesn't differ massively from grading SDR content, but it does come back to something I talked about earlier. I think I've mentioned a few times now, which is we're not just trying to make the image brighter. Generally, if I was viewing this on an HDR display, the sort of midtones are roughly where I would want them. It's not too crushed, it's not too dark. There's still some detail in there, and the blue sky is highlighted quite nicely. So really what we're just trying to do is we're trying to make use of the expanded dynamic range. We might pull the absolute shadows down a little bit further, and then the sort of specular highlights, push them up a bit so we get the really bright sort of fringes to the cloud here. But I'm not just going to, grab my gain control here and bump everything all the way up. It's just not how we do HDR grades. It's just because it's bright, just because the displays can't have a higher maximum brightness doesn't mean that we're just going to make everything suddenly 10 times brighter. So generally what we would do is the same. And what I'm going to do is I'm actually going to apply a grade here that I've got on a still. I'm going to apply this, and what you'll see on this this grade that we have here, it's got quite a big sort of node tree in here. It's been balanced already. Someone has, if I open up Windows, someone's already masked off all these different parts of the image, thrown in different masks. And then we've got a few different nodes down the end here as well. So really, I'm not going to bother with the first part of this node graph. I'm not going to bother with the balance node or the sort of node, all the parallel nodes that have the masks on them. I'm just going to look at these last two controls here and how you would have previously graded HDR footage in Resolve before Resolve 17. So for this, I'm going to go to my my color wheels, but instead of using the primaries wheels, I'm actually going to switch across to the log wheels. And the reason I'm switching across to the log wheels is because they give me greater control over the range of the image that I'm or adjusting. So I have in my log wheels here, I have a low range and a high range that basically limit the range of the shadow and highlights controls. So if I have a really sort of high low range, I can adjust, whoops, make sure I'm selected on the right node. If I have a really high low range, my shadow control now controls quite a lot of my image. But by default, you'll see that it actually only controls sort of the very sort of darkest parts of my image there. And the inverse is true of the high range. So if I was to increase the high range, my highlights now should, if I lower the high range, I now control more of the image. Whereas if I raise that up, you can see, by default, I'm only controlling the absolute sort of top end of my image in there. And again, whilst an HDR image doesn't show correctly in the Resolve viewer, if you sort of keep your eyes up here on the sort of highlights in the clouds, you should be able to see some changes. I sort of raise those highlights there. So generally, what we'd have done before Resolve 17 is used our log controls to set our balance. So I might pull my shadows down a little bit, not too much. Again, I'm not looking to sort of crush all the detail in my image. I might only pull that down to about there, and I might push up the highlights a little bit as well, just sort of in that range. And I can disable the node, sort of see the before and after. I've sort of stretched it out, I've increased the contrast, and I'm sort of leveraging more of that dynamic range. Now, if I wanted to go in and adjust, even less of the highlights, the very sort of specular highlights, what I'd have to do is I'd have to use a second node. And in this node tree here, we've got the HDR log, the HDR log that we have done our sort of rough contrast adjustment on. If I select the second HDR node that I've got in my node tree here, you'll see now that the high range is much tighter than the high range in the node before. So if I just sort of jump between those two, you'll see that the high range is, 0.1 higher. So now if I make an adjustment to the highlights, I'm really just affecting the highlights. Or the really sort of specular highlights there. So like this sort of section in the clouds here, again, if I enable and disable it, you'll see there's just the tiniest little bit of adjustment here. And the same for the shadow. The low range is a lot lower. So now I can really sort of pull down the blacks in the image and just sort of crush them there. And that's it. If I wanted to isolate different parts of the image based on, luminance and control, generally, previously would have done it using the log wheels. And, as you can see here, I've done this just using two nodes. It can start to stack up. You can start to end up using quite a lot of nodes as we go through this. But we don't need to do this now in Resolve 17 because we have a whole new set of tools, the HDR wheels or the HDR tools. And what I'll do is I'll reset my node grade up here. And I have another still, so I'll apply that. And you'll see the majority of this sort of node structure is the same. I've got the same noise reduction node, same balance node, the same windows. But after the fact, I also have just one node. Whereas previously, I'll switch across, I had, one for the sort of general contrast adjustments, then for the sort of specular highlights and the blacks. And then, if I wanted to go in and adjust contrast even more, I could have done using the curves as well. So rather than have that, if I just go to my my other grade, I've only put one node after the parallel mixer here. And the reason for that is if I switch across to the HDR tools, you'll see that I don't just have 4 wheels now. I don't just have, shadows, midtones, highlights. I have black, dark, shadow, light, highlight, specular, and then global as well. And these are all the different ranges or zones that the HDR tool works in. If I click on this sort of button here to expand the HDR palette, you'll see that for each of my wheels or each of my zones, we have different levels here. Now, the first thing to sort of take into consideration before I start doing anything is right now, if I sort of scrub through, we have a waveform here, but if I go to this little 3-dot menu in the top right corner, you'll see that it's currently set to work in the timeline color space, which if it was, in this case, the timeline color space, if I go to custom, is DaVinci Resolve Gamut. But if I was to turn this off, say, or change this to be, you know what I'll do? I'll go to SDR Rec 709. If I was changing that to be Rec 709, you'd see now that it limits there at about 108. But if I go into my color space controls, I can set that manually to work at my DaVinci Resolve Gamut and DaVinci Intermediate options in here. If I wanted, if I was working for P3, for example, P3 D65 with ST2084 1000 nits, I could do the same thing there as well. So there we go. You can set up the tools to work in the range that you want, or if you're using color management and you've set up your timeline controls and you're happy with those, you can leave it to set to use the timeline controls. And then we can just go through and we can start doing our grade. The thing that these different zones give us is a different range of control, or a different set of ranges to control, I could say. So for example, if I come all the way down here to the blacks, or the black controls it's called, and I start adjusting that, you know what, just change this back out to DaVinci Resolve Gamut for just now. There we go. And I start adjusting this. I'm really only adjusting the darkest parts of my image. The absolute darkest parts of my image are what I'm working with here. If I move across to dark, you'll see I'm now working with a little bit lighter, couple of nits sort of down. If I start adjusting this and you look on the parade sort of below, maybe 2 or 3 nits, I'm starting things to control with that. Shadows, I've got a bit more. I can go in, I can adjust that. I might pull this down a little bit more. But 1, 2, there we go. I pull all that down. And I could go all the way along. I could go through all these controls, light, if I wanted to raise that up a little bit, if I wanted to make my image just a little bit brighter. Again, I don't want to make it too bright. I don't want to have, the majority of my image sitting over the sort of 100 nits range, because really I'm only going to save above that for the specular highlights. Now I might have, up to sort of 200 or 300 nits with standard highlights, but really sort of anything above that is only going to be saved for the brightest parts of my image, because again, we're not just trying to make our image significantly brighter, we're trying to leverage as much of that dynamic range, that high dynamic range as we can. So if I come along to, the specular highlights here, I can start to push them all the way up, and the same with the highlights as well. So really, again, it doesn't come across all that well in the Resolve viewer. If we had an HDR viewer connected via an I/O card, our highlights here would be sitting around, sort of 600-700 nits. So it'd be significantly brighter. The other advantage of the HDR tool is not just the different zones for control. It's also worth noting we can make new zones as well if we want to. We can have as many zones as we want, depending on how much control we want to have. But we can also control the saturation for each of those zones independently. So it's not just a sort of global saturation control now. It's not like we have to isolate specific parts of the image using the qualifier and then adjust the saturation for that, we can actually go in and based on these zones next to the exposure control that I've been using, there is also a saturation slider as well. So you can see if I slide that up in the highlights, we start to get a lot more sort of purpley blue in the sky and a lot more red in the clouds there. If I wanted to pull all the color out of the darker parts of the image or the shadows or anything like that, I can do that using that saturation slider on the HDR controls there. So really, everything that we would have done across 3 nodes or 4 nodes or however many nodes we needed in previous versions of Resolve, we no longer need to do with Resolve 17 because of this HDR, this high dynamic range tool set that we have down here. So there we go. That's a quick sort of how we would grade an HDR clip in Resolve. Like I said, it's not significantly different to how we would do an SDR grade in Resolve, and it is also worth noting that we would do we can use the HDR tools on SDR content. There's nothing that would stop us from doing that. If we want, more control, we want to use all the different zones in an SDR image, then we can do. There's nothing that would stop us from doing that. Another handy little thing that's in the HDR tools, actually now that I think about it, is the button in the top left of each of the wheels. If I click on that and just click and hold, it actually shows me the area, the range of the image that I'm affecting with each of those controls. And I can do that for all of them. So, from the dark parts all the way up to light, the highlights, and specular as well. So you can really get in and fine tune exactly what you're adjusting. So once we've finished the grading process, once we've graded our image and we're happy with it, if we're doing an HDR grade for Dolby Vision or HDR 10 plus, you would generally do what's called, you would do what's called a trim pass. You would analyze the file and then try and tone map it to an SDR display or to a lower neat value display, because obviously not everyone has an HDR display at home. So your content needs to be viewable by the widest audience possible. If you're only putting out HDR content, then you're cutting off, just an incredible number of viewers. So this is where we do an SDR grade or a trim pass. And rather than start from scratch and try and grade it and balance it all, or just sort of throw a lot on and hope that it all comes in line, there's a set of tools for both Dolby Vision and HDR 10 plus in Resolve to do this. So if I come back to my project settings and go to color management, we have Dolby Vision and HDR 10 plus here. I'm going to enable both of them for just now because we'll go through them all separately, but I'm enabling them both for just now. And what's going to happen is once I've enabled these, I'm going to get some more tools, more tool palettes that appear in here. So if I hit save, you'll see now that I have Dolby Vision and HDR 10 plus that have appeared over here. What we're going to do is I'm going to start on Dolby Vision, and what we're going to do is we're going to tell it the target display output. So I've done my grade for P3 SD2080 1000 nits, but I also want to view it on an HDR display and make sure that everything comes in line and then do a trim pass on it as well, and make sure that when we're doing the tone mapping, everything isn't sort of blowing out or we're not mapping things weirdly. I can choose what target display I want. There's options here for 1000, 2000, 600 nits or 100 nits. I'm going to go with 100 nits SDR because that's generally, what most sort of trim passes will be for, just for the sort of broadcast and home viewing displays. And then I can analyze either all of the shots on the timeline, selected shots. I'm just going to use the one shot that I've worked on, this sort of single shot. And if I analyze that, you'll see all of a sudden my colors are a lot more vibrant in the Resolve viewer. The contrast seems to have been bumped up significantly, and that's because we're seeing a tone mapped preview, which I can turn on or off. So as we mentioned, the Resolve UI doesn't show HDR content, but this is our tone mapping preview. So this is, you know, roughly our HDR image sort of scaled back. So when I said, you know, this image, trust me, looks significantly different on an HDR monitor, you know, it looks significantly different when we map what we've done on HDR back down to SDR. So what Resolve's done there is it's generated the Dolby Vision metadata that goes with this. And if I had a Dolby Vision license, I would have access to these primary and secondary trim controls here. Now, the Dolby Vision license isn't something that Blackmagic sell or, you know, that we sell. It's something you get from Dolby themselves. So it's not something, you know, I have access to. But if I had that license, I would then be able to, you know, adjust things like lift, gamma, gain, you know, saturation, weight, all these sorts of things to try and get my SDR grade in a sort of pleasing where I'd like it to be sort of range. You can do the same for HDR10, but instead of analyzing shots down here in this palette, we come up to color as the drop-down menu. You'll see we now have HDR10 at the bottom there, and I can analyze, you know, that selected shot, and I can do the same thing, enable and disable the tone mapping controls. Now, there's a difference. You'll notice that the trim controls are grayed out here, and that's not a license thing. It's actually, from what I understand, the people behind HDR10 Plus have basically just said, no, just leave them grayed out, leave them as they are. The transform, or, you know, the analyzing and tone mapping is fine as it is. So that's why they're grayed out here. But that's basically it. We've generated the HDR10 Plus metadata for our HDR grade there as well. And if we wanted to export these at any point, you know, if we wanted to export the metadata separately from doing it on the deliver page, if we just wanted the metadata, we're going to sort of combine it after the fact, you know, we can do that. If I open up the media pool here, if I right click on the timeline itself in the media pool and go to timelines, export, you'll see under export, I now have a Dolby Vision XML or an HDR JSON file. So I can actually export just the metadata from within Resolve just by right clicking on the timeline and going to timelines, export, and then selecting whatever it is I'm working on. So there we go. That's generally what we tend to sort of look at when it comes to doing the trim pass. For a bit more sort of understanding on the trim pass, it can be a little bit tricky to sort of go through all at once. So there's a few sort of visual representations and things to sort of, you know, go through just to sort of try and explain it a little bit. So the way that a Dolby Vision workflow tends to work once you've done your analysis is got source content. We've done all the setup in Resolve, so all of our pipeline stuff, you know, whether it's or, you know, Resolve color management or ACEs we're working with, and then we have our monitoring output here, and this is where we need two SDI outputs because one of them is going to output our HDR 1000 neat master or whatever standard you're grading to, and the other is going to be used for our 100 neat trim pass. So as Dolby Vision requires a dual SDI output to see the HDR and SDR trim pass, like we said, a dual SDI output is needed on the I/O device, and that's why we're using an Ultra Studio 4K Extreme here, and why the Decklink Mini Monitor 4K won't work. It's worth noting, from what I understand, it's worth noting that the Decklink 8K Pro is the only I/O card that will output two 4K signals simultaneously. So if I was using, you know, the Ultra Studio 4K Extreme, you know, my HDR output might be 4K, but my SDR would be, you know, downscaled to 1080. From what I understand, only the 8K Pro will do dual 4K outputs. Oh, look at that. I am incorrect in that the initial output would be HD from both of them. It wouldn't be UHD on one and HD on the other. It would be HD from all of these. DeckLink 8K Pro is the only one that will do UHD on its output, on both outputs. So there we are. Now, we talked a lot about the metadata when we were talking about the trim passes there. And basically the metadata just contains things like all the tone mapping values for, you know, how we get from our HDR to our SDR file and vice versa. So all of that metadata can either be exported as an XML, you know, separately from the timeline, as we looked at there by right-clicking on the timelines, or if we're doing an IMF delivery, an interoperable mastering format, I think it is, delivery, an IMF delivery, it would be included in there. If I jump back into Resolve and go to the deliver page, along the top here, I can select IMF, and you'll see we have IMF and type. So we have Dolby Vision, HD, 2K, UHD, 4K. So when we do one of those deliveries, we will include the HDR metadata that goes with it. And that metadata is what triggers the Dolby Vision engine and whatever display we're looking at or viewing the content in there. So the metadata for Dolby Vision and HDR10 Plus is what we refer to as dynamic metadata. So it holds like the maximum neat value for every single frame in the rendered file, so that all the tone mapping is far more accurate, and it tends to be better suited to like ABL, automatic brightness limiting, as well. So generally, the other thing is generally the trim pass that we've done makes it backwards compatible as well. So if, you know, someone's viewing, you know, a grade that we've done and they don't have an HDR capable display, because we did that trim pass at 100 nits, the file that they see would be the trim passed version, not the HDR version with clipping or anything like that. HDR10 workflow is pretty much the same. It's very similar in terms of the way it works. What you can do in theory is, because HDR10 Plus works in Rec 2020, you could use a domestic TV to sort of replace your mastering monitor. As we mentioned, you know, we'd only recommend that, you know, if you know the limits and things like that. But you can do it in this case. But the thing to be aware of is obviously the domestic TVs don't have an SDI input, and they need to be triggered into HDR mode. And that's where we had, if I jump back to Resolve, that's where we had the enable HDR metadata over HDMI tick box to enable that flag in the HDMI signal to trigger a TV into HDR mode. Obviously, that wouldn't work if we were converting SDI to HDMI with just any random SDI to HDMI converter. So you'd need something like the Terranex Mini SDI to HDMI 8K, which can transmit the VPID tag that triggers the HDR metadata. So a little bit more of a complex workflow, but only if you want to use, you know, like a domestic TV for HDR grading. If you want to, you know, use an SDR display, an HDR display with SDI, like we did for Dolby Vision, then the workflow's, you know, the same really, and you get the same sort of idea in terms of the metadata. So once the trim pass has been adjusted, the metadata is exported as a JSON file rather than as an XML file, like it is with Dolby Vision, just because of the different standards really and how they're built. But the idea is you export, you know, a high quality 444 file with the HDR 10 plus JSON file, and they're merged together as a single deliverable file. It's worth noting that this isn't supported in Resolve. Resolve doesn't support, merging the two files to make one single file. There are third-party applications you can get to do that, but it's just not supported in Resolve. So it is something to be aware of. So again, this only really needs one grade, like Dolby Vision. It only really needs one grade because we're doing our HDR grade, we're doing our main grade in HDR, then we do a sort of quick trim pass to make sure everything's okay, and then exports it. And then the metadata will, whether it's SDR or HDR, display the correct content for the end user. One that's sort of slightly different to this is HDR10. And HDR10 delivered files in the HDR10 workflow, it gets a bit tricky because there's HDR10 and HDR10 plus. So it's a pain. But HDR10, the way that it works is it doesn't do a trim pass. There's no trim pass with HDR10. So because the files don't contain any sort of trim pass metadata or anything like that, you need to do two separate grades. You need to do a HDR grade and then deliver a separate 709 SDR grade as well. And that's sort of shown here, whether it's RCM, Resolve Color Management, or ACES that you're using, you will do one full grade as ST2084 RIT 2020, and that's what you'll monitor it at as the time. Then when you come to do your SDR grade, you don't do a trim pass, you don't have the sort of automatic tone mapping or anything. You've got to do a whole separate grade for that. And at that point, you'll monitor that in Rec 709 with the BT1886 EOTF. And that's it for metadata, or it's the same idea with the metadata, really. HDR10 uses static metadata. It doesn't use dynamic metadata. So there isn't a, if the display that you're viewing on doesn't have a Dolby Vision or an HDR10 plus engine, they'll default to using static metadata. But that basically means that there's just sort of one max CCL and max fall, which I think, from memory, I don't have it in my notes here. I think it's like max content, I can't remember, max something luminance, and max fall, which is like max frame average light level or light luminance, something along those lines. So that's the static metadata that the HDR10 uses. But what you can see here is, unlike our previous deliveries, so find them, Dolby Vision, where we do, you get your HDR render and your XML as a single sort of output. That's it. That's everything you need for both HDR and SDR, and the same concept for HDR10 plus. When we're looking at HDR10, we're looking at the HDR file with the HDR metadata, and then a whole separate SDR grade in there as well. Final one that it doesn't really have a mention because there isn't any metadata that goes with it, and that's hybrid log gamma. It doesn't use any metadata, but because of its hybrid nature, because of the backwards compatibility that's inherent in the EOTF, it only uses one grade. You do your full grade, and when you display that in an SDR TV, it tops out at 108 like it would with a standard SDR grade as well. So that's it really in terms of HDR. I know that's been a lot to digest. We've covered a massive amount there, and we're only sort of scratching the surface of HDR and HDR within Resolve. There's a lot more to get stuck into, and it's emerging technology. So there, there's, like we said, we've covered 4 standards there. There's more standards than that. You can learn, all about all the different standards you want, and there's always going to be developments in them. So it's very much an intro to working with HDR. If there are any questions on this, or anything Resolve related, don't hesitate to contact the Scan Pro Video team. Will help as best we can. But I just want to take this sort of time to thank you for sitting through quite a long and technical presentation. Hopefully it's been helpful, and we're trying to put on as many of these as we can for you, generally doing one a month in conjunction with Blackmagic around Resolve. So hopefully we'll be able to continue to do that into the future. But yeah, if there's anything that comes up, if you want more information, if you are interested in Resolve or the I/O devices, you want to know a bit more about HDR, contact the Scan Pro Video team. And thank you. I hope you have a good day.
For more information on any of the products and solutions mentioned in this webinar, contact the Pro Video team today. And you can also shop our Blackmagic design range at Scan Pro Video. If you haven't checked out our other sessions yet, then head over to the Pro Video YouTube channel and search Blackmagic Design Webinars. Thanks for watching.